Algebra I 11.6b, Subtracting Radical Expressions. Now, as I said in 11.6a, you need to watch 11.5a and 11.5b. And now that we did 11.6a, you should watch that one too if you want to fully understand this video. They're all in the description of this video as a link, so you can just click on them. You need to understand dividing rationals and rationalizing the denominator and adding them before moving forward, or you're going to get lost. So, as we've said in the previous video, when we have radical expressions that have the same radicands, we can subtract by using the distributive property, but the radicands must be the same. So we can have 5 times the square root of 5 minus 3 times the square root of 5, and we just do 5 minus 3 times the square root of 5. That's going to give us 2 times the square root of 5, see? And that doesn't equal 10, we just leave it like that. That's simplified, okay? You can't simplify it if the radicands are different. You can't have the square root of 5 take away square root of 2 and get the square root of 3. It doesn't work that way, okay? And as we said in the previous video, if there's a number in front of the radical sign, that's a coefficient. And sometimes there's an invisible one there that can help us, okay? So if we want to subtract the square root of 2/3 minus the square root of 1/6, what we can do is we can rewrite them so they each have their own little tiny radical sign, okay, for the numerator and the denominator instead of the one big one. And then we can rationalize the denominators for each denominator. So rationalizing this denominator, we multiply by 1 as the square root of 3 over the square root of 3, and that's going to give us the square root of 6 over the square root of 9, isn't it? And the square root of 9 is a 3, so that gives us the square root of 6 over 3. So now that one's been rationalized. So now let's rationalize this one. We're going to multiply the numerator and denominator by this as 1 by the square root of 6 over the square root of 6, see, because that's the denominator. So we get the square root of 1 times the square root of 6 is the square root of 6 over the square root of 36. And the square root of 36 is a 6. So now we've removed the radical signs from the denominators. You can't have an answer with a radical sign in the denominator, okay? That's why rationalizing is so great. Now you don't need to do this part if you just know to pull the radical sign off of this and it's just a 3, see? Pull the radical sign off and it's a 6, okay? Same thing. So now we've got the square root of 6 over 3 divided by 3 minus the square root of 6 divided by 6. And we need to find common denominators. We can't subtract with the different unlike denominators, can we? Just like in grade school. So what can 3 and 6 meet at? They can meet at 6, can't they? So 6 is going to stay the same. We're not going to do anything to him, but we're going to multiply the numerator and denominator of this one by a 2 for each so that we can get them to be at the same denominator. So 2 times 3 is a 6, and 2 times 6 is a 12. So now we've got square root of 12 over 6 minus square root of 6 over 6. See? Now, because they have the same denominator, we can just subtract. And square root of 12 minus square root of 6 is square root of 6 over 6. See how I did that? Quite a few steps to it, but the most important one was rationalizing the denominator for each of these rational expressions so that we could get rid of that radical sign, right? And you see how I did it? I multiplied it by a 1 as the denominator over the denominator. See that? And that rationalized it. Then we just found a common denominator. Okay, this one's a little bit more difficult, okay? We've got the square root of 1/12 minus the square root of 1/27. All right? So this is how I solved it, and I'm going to go in very tiny little steps so that you can follow me, okay? So I split it up so that each numerator and denominator had their own little radical sign, okay? Then I rationalized the denominator. So we have to get rid of these radical signs. So I multiplied this 12, this square root of 1 over square root of 12 by a 1 as the square root of 12 over square root of 12, the denominator over the denominator, and that's square root of 12 times square root of 1 is the square root of 12, and the square root of 12 times square root of 12 is the square root of 144, right? Or we could have just pulled the radical symbol off and just did the 12, right? Because 144 is 12 times 12. All right? So now we just have a 12 down here. All right? So stay with me. We have to rationalize this denominator, so we multiply denominator by over denominator to this side, and we get the square root of 1 times the square root of 27 is the square root of 27, and the square root of 27 times the square root of 27 is square root of 729, which is 27 times 27, right? So we can pull the 27 out and put it here, see? So now we've got the square root of 12 over 12 minus the square root of 27 over 27. And we can open these up, can't we? The square root of 12 is 3 times 2 times 2. It's 3 times 4, isn't it? And we get a nice little pair here. See? We get a nice perfect square. 2 times 2 is 4. And for the 27, we've got 3 times 3. Because 3 times 9 is 27, isn't it? So we have a nice little square here, too. 3 times 3. So we can pull out one of these and put it in front with the square root of 3. Because when we pull one out, the other one disappears. See? We can pull one of these pair out and put it in front, and we're left with square root of 3. Now this is what we've got. We've got this as our problem. And if you look at this very carefully, you'll see 2/12 and 3/27, and we can simplify 2/12 and 3/27. 2/12 becomes 1/6, 3/27 becomes 1/9, and they both have that square root of 3 in the numerator there, see? Now they've got a 6 and a 9. We can find a common denominator of 18. What does 6 need to be multiplied to get to 18? A 3. And the numerator gets jealous. It wants to be multiplied by 3. 9 needs to be multiplied by a 2 to get to 18. So the numerator has to be multiplied by 2. So now we do it. And we remember there's an invisible 1 in front of here, isn't there? We don't have to write this 1 if we don't want to. But it helps when we're doing the math. So 3 times 1 is 3. So that's 3 square root of 3. And it's over 18. And this side is 1 times 2 is 2 square root of 3 over 18. And now look, we've got the same denominator, and now we can do our subtraction. We end up with 3 minus 2 square root of 3 over 18. And 3 minus 2 is a 1. We don't have to write that 1, do we? So we can just put square root of 3 over 18. A lot of steps to that, wasn't it? That's why I thought it would be good to make this extra video on subtraction so that you could see how I did this. It's very important you rationalize each denominator to remove those radical signs, okay? And then I factored them and opened them up, didn't I? And was able to pull out a perfect square and put that in the front and put that in the front. And then I simplified them, the 2/12 and the 3/27. Then I found a common denominator, and by simplifying them first, I didn't have to find a big, huge common denominator like 108. I could have done that, but it was easier to simplify these fractions to smaller numbers and then find a common denominator. Then I could just do 18, because 12 and 27 have 108 in common, but I don't want to multiply by big numbers like that, right? So we ended up with not having to put our 1 in front, and we could just write square root of 3 divided by 18. All right, our next video, 11.6c, we're going to talk about conjugates, all right? You talk about those in Algebra 2, but there's a little section in your Algebra 1 book that mentions it, so I thought I'd introduce it to you, all right? And of course, I've got all the links in this description that can help you if you're confused, all right? So if you're lost from this video, go back to 11.5a in the playlist, then 0.5b, then 0.6a, and then watch this one again, and it'll all make sense, okay? Just like playing a video game. You can't skip a level and know what's going on, or watching a movie, you can't skip a part of the movie and know what's going on, right? You're going to miss part of the story. All right, I'll see you next video. Bye.